Okay.
Physics featuring Brittany Pond!
Thank you, Kaylee.
You're welcome.
Okay, so I'm just going to kind of go through. I've just kind of wrote out a few basic things, so I don't have to do it now. So we have kind of our problem is number 2 on the sheet, and we have a cannon fired at 15 degrees. And the initial velocity is 25 meters per second. And then I just kind of have my 2 tables. And so this table is going to be used for me to find out A, which is how far away it is. And then I have this table down here, which is going to be B, and it's trying to find out the max height. And I've circled what I'm looking for. So here I'm looking for, the delta D in Y, and here I'm looking for the delta D in X. So now we're going to come over here to this little triangle right here, kind of fill in. So we have 15 degrees is the angle that we're looking at, and then we're looking at the hypotenuse right here is 25 meters per second, and that's the V. And so we're looking for here, which is the distance of the object, the initial distance in Y, and then here is the initial distance in X. And the way we're going to find that is we're going to do some SOHCAHTOA, some math. And so we have sine of 15 equals DIY over 25. And if we multiply that out, we get 25 sine 15 equals DIY. And then if we do the math out for that, we get 6.47 meters per second. We can fill that in our chart, 6.47 meters per second. And then if we do cosine of 15 equals dix over 25, and then we multiply the 25, we get 25 cosine 15 equals dix. And then if we do that out, we get 24.15 meters per second, and we'll do 24.15 meters per second. And so now we're going to use this information on the left side to find the time, which we're going to use to find this DI. And then we know this is 0 meters per second. We know that because it's at the maximum height, there's the velocity 0. So now we're going to plug that in. And we're going to do 0, which is the VF. We'll do it right here. 0 equals, I'm using this, 6.47 T. So we have VI T plus 1/2 negative 9.8, which is our acceleration, T squared. And I'm just going to kind of cross off this T and then, one of those T's now. And so then we are just left with, if we subtract this 6.47 and then do that out, we have negative 6.47 equals, and then if we multiply that out, that's negative 4.9 T. And we divide by negative 4.9, we get T equals 1.32, so we'll fill that in, 1.32 seconds, 32 seconds. And then to find the delta D, we have delta D equals the VI, so 24.15 times the time, 1.32, and if we do that out, we get delta D equals 31.89 meters. So this would be our, how far away our object lands would be 31.89 meters. So this 39.81 meters. And so now we're going to come down here and we're looking for the max height. And so we're going to kind of refill in some of these things. We have 24.15 meters per second, 6.47 meters per second. And then we have this is negative 9.8 meters per second, and we have 1.32 meters per second. Luckily for us, the only variables we really need for this are this and that, and this, which is the given we have the VF of y. And so what we're going to do is we're going to plug it in. We have VF squared, so 0 squared equals 6.47 squared, so we have the VI squared, plus 2 negative 9.8 delta D. And if we square this, we get equals 41.86 minus 19.6 delta D. We're going to subtract 41.86 and move it to that side, so we'll have negative 41.86 equals negative 19.6 delta D. If we divide by negative 19.6, we have delta D equals 2.14 meters. And so this would be our maximum height. I keep writing that. Our maximum height would be 2.14 meters, which we're going to do that up here. This height right here would be 2.14 meters. So we have our maximum distance would be 3.89 meters, and our maximum height would be 2.14. That's all we have for today, folks. Thank you very much.
Physics.
Thank you, Kaylee, for filming.
Woo.